Hello and welcome to Space Shark Teaches. I'm Sean from Space Shark Studios, and I'm here to teach you GDScript in Godot 3.1. Let's get started. So I should have seen this coming after making a video on how to make your little thing, sprite, I guess, look at the mouse. We are now going to make a sprite follow the mouse. So to start with, I made a kinematic body, added an animated sprite and a collider, just like you're supposed to, and then I added a script. Right now, it is empty. We're going to be filling this out. The first thing to do, because I haven't made this in GDScript yet, is to make a look at mouse function and call that from process. So look at mouse, if you've seen the other document, uses look at and then get global mouse position. That's basically it. You see this though, the problem is it's looking out from the right side. If you have a sprite like mine that looks up primarily, then you need to do just something real simple, which is we get the rotation in degrees and then we set it to rotation degrees plus 90. So that will rotate it around by 90 degrees after we do look at. And there, we are now looking at the mouse pointer. That was really simple. Next, we are going to do move to mouse. And then of course, add move to mouse to our process. Now we're going to need two variables for this. One is going to be move speed. And let's actually just start with move speed. So that will be the first thing we add is this move speed of 250. So what do we do for move speed? Well, first we have to get the direction that we're going to be moving, which is going to be the global mouse position minus the position of our spaceship. And then we can just do move and slide with that direction. So this is the most basic way to set it up. So the problem with this is you will move faster the further away you are and slower the closer you get. If this is fine with you, then you can stick with that. There are a lot of fun things you can do with it. We're going to use this move speed though, which means we first have to make a normalized direction. What normalized means is it takes this direction vector, so let's say you're going up this way, and it scrunches it down to a distance of 1. So as you can see, well, we haven't actually changed that yet. If we used normalized direction here, we are going to go very slowly. So you can see that it's barely creeping along. You can see the changes in the pixel, and that's about it. What we want to do here is take the normalized direction and then multiply it by move speed. And now we have a rocket ship that goes 250 pixels a second. Awesome, that seems great, right? Well, as you can see, it lands and it's all over the place. So let's go ahead and add that second variable I was telling you about, which is stop distance. Let's set that to 20 because our spaceship is 20 tall, or 40 tall, so it's 20 in the up. So what does this mean? We want to see if the distance between let's do it this way. The distance between our position and the mouse is greater than the stop distance, then we want to move. So this says if the distance to the global mouse position from our current position is greater than our stop distance, then we get the direction, normalize it, and move in that direction. And there we go. That easy. So if you want to make it slow down also, I think we can do it this way. You can, instead of normalizing it, is there a min? Yes. So right now we have the direction that we need to go, and we can use that instead. Right, so let's go ahead and cancel that out. So remember, the direction is really the complete distance, or the vector that goes from our position to the mouse. So what we want to get is, now we want to get normalized first. Var direction distance equals direction.length, and then we want to multiply this by the maximum of move speed, or the direction distance. Now that moves the same thing that we did before. Min. Min is what we want. So you can see it only goes up to our maximum move speed, but it will slow down as we get closer. So we can actually even do, if we want to say max move speed, min move speed, do 50. Rearrange these a bit, and now we can say we want to get the maximum of min move speed and these two. So if this ever goes below our minimum move speed, we'll choose our minimum move speed. But if we ever go faster than our maximum move speed, we will go our maximum move speed. So this will let us control, and it will never slow down more than we want it to. So you can see, instead of, it kind of gently goes in, but it doesn't slow down so much that it just seems too slow. So it's going into docking procedure. And that's it. Now you have a couple different ways to control your move speed, and it will move towards the mouse. Have fun. Thank you for watching Space Shark Teaches. If you'd like to see more, please subscribe to the channel and remember to click the bell to always stay up to date. Please also join us on our Discord, linked in the comments, and check out our other videos if you ever want to see what else we've been up to. Thanks again for watching, and we can't wait to see what you make.